Namaste dosto. Imagine you have a big jar full of colorful marbles and you want to find out how many of each color there are. If you just list the counts on paper, it can get confusing. But what if you could see the data in a picture? That's where graphical representation comes into play. Graphs let us turn numbers into visual stories. They show patterns, trends, and comparisons clearly and quickly. So even a glance tells a tale. When we deal with large data sets, especially frequency counts of groups or classes, graphs help us understand the whole picture without drowning in numbers. Some popular ways to visualize such data are bar graphs, histograms, frequency polygons, and ogives. Each has a special use depending on the kind of data and what we want to learn. Mathematically, these graphs plot group data points like x sub I, f sub I, class intervals and their frequencies onto coordinate axes. We use shapes like rectangles or connected lines to make comparisons easy and obvious. For example, histograms and bar graphs might look similar but have subtle differences, like how their bars are spaced or arranged. Here, think of a histogram with rectangles touching each other, each labeled with class intervals and frequencies, versus a bar graph where bars are separated. So, with graphs, we can spot trends and outliers, make comparisons across categories, and draw conclusions faster, much better than sifting through rows of plain numbers. Ready to explore how to build these graphs? Chalo, let's move ahead. Let's now understand what we mean by a grouped frequency distribution with equal classes. A histogram represents class intervals using adjacent rectangles, with each rectangle's area proportional to the frequency. It is mainly used for continuous data, where values flow smoothly from one range to another. When the class intervals are of equal width, the height of each rectangle directly represents the class frequency, denoted by f sub I. So, in this case, the formula becomes height equals f sub I when the width is constant. One important rule to remember: in a histogram, there should be no gaps between the bars because it represents continuous variables, unlike bar graphs where spacing indicates separate categories. In summary, a histogram with equal class widths shows frequencies through continuous, gapless bars, where height equals frequency when the width remains constant. Let's talk about adjusted frequencies for fair comparison. When the class intervals are not all of equal width, we can't just use the raw frequencies directly. They have to be adjusted so that the area of each rectangle still represents the correct frequency. The formula for this adjustment is height equals f sub I divided by w sub I, where w sub I is the width of the ith class. This adjustment ensures that the area, which is height multiplied by width, correctly reflects the frequency for each class. By normalizing the heights this way, we can make a fair and accurate visual comparison, even when the classes have unequal widths. Let's understand how to overlay a line plot on rectangular bars. A frequency polygon is created by joining the midpoints of class intervals with straight lines. This helps us see the overall shape of the data distribution clearly. To construct it, first mark the midpoints of each class. The midpoint, or x sub I, is calculated as the lower limit plus the upper limit, divided by 2. Then, plot these midpoints against their corresponding frequencies, represented by f sub I. Finally, to complete the polygon, connect these plotted points with straight lines. You can also extend the line to touch the x-axis at 0 frequency on both ends for a closed shape. A frequency polygon can also be drawn on its own, without the histogram. To create it, you simply use the grouped frequency table and plot class midpoints against their corresponding frequencies. Once you have the points plotted, connect them one after another. Each point is represented by x sub I and f sub I. Then, join the end points to the x-axis using assumed boundary midpoints to close the figure. This approach is especially helpful when you don't need a histogram and only want to show the overall pattern or shape of the data. Frequency polygons are also commonly used in statistical summaries and in comparing different distributions to study trends and variations. Let's understand the difference between categorical and continuous data. Bar graphs are used to represent discrete or categorical data, where each bar stands for a separate category and the bars are spaced apart. In contrast, histograms are used for continuous data where the rectangles are adjacent, showing the continuity of class intervals. In a bar graph, the bars are uniformly spaced, while in a histogram, the bars touch each other to emphasize that the data intervals are continuous. Bar graphs are typically used to compare non-quantitative categories, such as favorite fruits or colors. Histograms, on the other hand, represent numerical data divided into ranges, showing how values are distributed. A key mathematical point to remember is that in a histogram, the area of each bar represents the frequency, while in a bar graph, only the height conveys meaning, the area does not. Let's learn how to draw a histogram when equal class intervals are given. We are provided with class intervals from 0 to 10, 10 to 20, and so on up to 50 to 60, with respective frequencies 5, 12, 20, 30, 20, and 13. Step 1. Plot the class intervals on the x-axis and the frequencies on the y-axis. Step 2. Since all the class widths are equal to 10, the height of each rectangle will be equal to the class frequency itself. So, the rectangles will have a width of 10 and heights of 5, 12, 20, 30, 20, and 13 respectively. Finally, when you plot and check, you'll see 6 adjacent bars of equal width, and the height of each bar accurately represents its frequency. Let's understand how to handle unequal class intervals while drawing a histogram. We are given class intervals with widths of 5, 10, and 15, and their respective frequencies are 15, 20, and 25. Step 1. Compute the height of each rectangle using the formula. Height equals frequency divided by width. That gives us heights of 3, 2, and 5 over 3 respectively. Step 2. Draw rectangles with the given widths and the computed heights. Step 3. Make sure that for each rectangle, the area, which is width multiplied by height, equals the corresponding frequency. The result is a histogram with non-uniform rectangle heights that still accurately represents the frequency distribution for each class interval. Let's quickly summarize what we've learned about the graphical representation of data. Formula 1. X sub I equals L sub I plus U sub I divided by 2. This gives the class midpoint. Formula 2. Height equals F sub I. This applies when the histogram has equal class intervals. Formula 3. Height equals F sub I divided by W sub I. This is used when class intervals are unequal. The key takeaway is that visual methods like histograms, frequency polygons, and bar graphs make it much easier to analyze and interpret frequency data at a glance.